In this video, we're going to go through the solution to the getAt method together. Now, before we start writing any code here, there's one or two extra cases that I want to tell you about. I specifically didn't mention these in the last video just to give you the chance to think about them on your own. So there are two edge cases that we need to kind of be aware of here. The first edge case would be the case in which we have no nodes at all. So maybe we have an empty linked list, but maybe some developer calls getAt on our linked list. We would need to make sure that we don't accidentally crash here or do anything like that. So again, we could do a simple check to see if we have at least one node. And if we do, then we could just go ahead and immediately, or excuse me, if we have at least one node, we can iterate through. Otherwise, if we don't have the head node, then that means we should probably immediately return something like null to say, no, we can't find that index or can't find that element. Now, the other thing I want to mention here as a possible edge case is if this method is called with some index that is outside of the realm of our linked list length. So if someone called getAt with an index of 12, well, clearly our linked list is not that long. So maybe we should handle that case as well. Now for handling that case, we could either call the getSize method, or just, the size method before we start doing any iteration and check to see if the size is greater than our index here. But recall, whenever we call size, that is going to iterate through our full list of nodes. So if we call size at the very start and then decide, okay, they are asking for a valid index, we would then iterate through our list again to find the appropriate node. In which case, we're essentially iterating through our entire linked list twice, which is obviously not the most efficient thing in the world. So we'll talk about another way of handling the case in which someone asks for an index that's out of bounds without doing that initial lookup of the size. Okay, so back inside my index.js file, at the very bottom of our class, we will add on getAt. Remember, this will be called with some specific index. And then just like we've done on several other methods, the first thing we'll do is check to see if there is a head node. So if there is not a head node, then just immediately return null, because we have nothing to iterate through, no more work for us to do, we're done. Now if we succeed in this check right here, then we will start up our main algorithm. So remember, our algorithm is going to take a node temporary variable that's going to start off looking at the first node and a counter temporary variable. We're then going to iterate through our list one node at a time, and for every step we will check to see if counter is equal to index. If they are not equal, then we will advance node on to the next node in the chain, and we will also increment the counter variable. So I'll set up my counter variable at 0 and my node variable to look at the first node in our chain, which is this .head. Next, we'll put together our while loop. So as long as there is a node present, as long as node is defined here, then there is something for us to do. So inside the while loop, we'll check to see if counter is equal to the index that we are trying to retrieve. So if these two numbers right here are equal, that means we have found the node at the given index that we're trying to find. So if this if statement is entered right here, we will immediately return node. Now if we don't meet this if statement right here, that means that we have not yet reached the index that we care about. And in that case, we will want to advance our node along and also increment the counter. So we'll say counter plus plus, and then to move along our node reference, we'll say the new node is going to be equal to node.next. So remember, if node.next, if we're at the end of the chain and node.next is null, then we will assign null to node right here. On the next iteration through the while loop, we'll look at the value null, that's falsy, and so the while loop will exit right away. All right, now the last thing we need to think about is the case in which we try to ask for an index that is out of bounds. So if we reach the end of our linked list, like let's say we go over to this node and we were asking for index 12, then we would increment our counter again, we would try to move node onto node.next, and it would now be looking at the value null, which is presumably over here. So if that happens, if we tried to look at a node of null before we hit this if statement right here, then we would just exit the while loop entirely. And so if we exit the while loop, that means that we were unable to find the correct node. So if we exit the while loop, we can simply say return null because, hey, we couldn't find it. You asked for an index that we did not retrieve while running the while loop right here. All right, now there's one more thing that I want to point out here, a little bit of code consolidation that we can do. So notice how the check to see whether or not we enter this while loop is to look at the node variable. And node is initialized at this.head. So if this.head is equal to null, we will never enter the while loop and we will immediately return null instead. And that's essentially exactly what this if statement up here was already doing. So in this particular case, the if statement is actually completely unnecessary because if this.head is not defined, node will be a falsy value, we will not enter the while loop, and we will instead immediately return null. So in this particular case, we can safely delete the if statement at the top. All right, that looks good. I'm going to save this file and let's see how our tests are doing. And yep, it looks like get@, is working correctly. Okay, so that is our solution for the get@, method. Let's move on to our next method, remove@, which is going to be another fun one in the next video. So quick break and I'll see you in a minute.